Hey everybody, I just wanted to share some exciting news with you. Shane has, finally completed the final specifications on our injected molded pumps. We released the order to a great firm in China, and now Shane's going to share with you and share with me some details about that injection molding. You're not going to see his face, but you're going to see his screen here in just a minute. Enjoy, enjoy.
All right, can you see my screen now?
I can.
So this is the mold, and it goes, an injection molding machine it's got one side that's stationary, and that's this plate here goes on the stationary side of the machine. And the stationary side of the machine is the side of the machine that melts the plastic and provides the melted plastic into the machine here, and this is what delivers the plastic into the mold. And then, so I'm going to make this invisible. So the plastic comes into the mold, and this red, if I isolate this, this is where the plastic comes into the mold. It's through this port here. And then so this is the bottom cavity of the mold here, and so this is one half of the cavity. So if I make this transparent, now we can see the pink here is our parts. So there's one half of the body, and if we come around over here, there's the plug, and here is the insert. And so a couple of changes that I had them make is this red, this gate tree. I had them change the location of the gates because they originally had the gate coming in right here on our sealing surface, and they had it coming in right here on our gluing surface. So I asked them to change that, so they relocated those gates where the plastic comes into the part, and now that's perfect because it doesn't come into the part, any of the parts anywhere that it will interfere with assembly or function. And then this half of the mold here, this mounts on a movable part of the machine, and that movable part of the machine is basically like a scissor lift that's been turned on its side. So imagine a kind of a giant scissor jack, or scissor lift that's been turned on its side, so that this half can be retracted and engaged. So this mounts onto a movable part of the machine that cycles, that reciprocates back and forth. When it closes, we have the base half here. It pulls this part apart, and that opens all the way up, and you can see everything inside the mold when that mold opens, so that it can eject the parts, eject the previous part. And this piece here, you can see this part of is for storage. So when they're storing the mold, they bolt the two halves together. Now this piece here, it not only can open and close, but it's got hydraulic systems in here that plunger this plate. And when this plate plungers, it's plunging against all these springs. There's these 4 springs, these super heavy duty springs. Those hydraulics plunge against those springs and actuate all of the ejector pins that push the part out of the mold. So when this opens up, these ejector pins push all the parts out of the mold and into a bin. This part of the mold is the moving part of the mold, and it houses the casting, the movable casting side of the mold, and I'll make that invisible. And now here's our parts again. So that part that I just made invisible is the part that houses this half of the cavity. So this molds the other side of the draft. So all of the mold is machined so that the two halves only have one empty portion for each part, and when this plastic is pumped in, it has to go into the empty portion and nowhere else.
Yeah.
But then all these green tubes, this is the cooling. So the mold has to be heated. So the mold is both heated and cooled, and these lines here, which are machined into the mold, these lines here allow the cooling to pass through. So you have these inlets and outlet, and same thing on the other side. You have inlets and outlet, and that ensures that all of the cooling can take place inside the mold so that it can cool down and the plastic can solidify.
What's the cycle time?
I don't know what the cycle time on our parts are. I'm assuming that they're, so our parts have a little bit thicker wall because our parts, one of the functions of the body of our pump is that if a system is mechanically impacted, so let's say, for example, there's no plants growing in it and somebody decides to stack a bunch of stuff on our system,
yeah,
the lid of the bottom system really isn't strong enough to support that weight. So our pump and its housing is actually a weight supporting structure. Should somebody stack something on the system and start to collapse that lid, the pump will support that weight until it becomes so much weight that it punctures a hole in the bottom of the bottom container, which would obviously take a lot of weight. But I wanted to make sure that our pump is not the weak link.
Yeah.
I want to make sure that if somebody stacks something on the system when it's not in use, when it's put together but not in use, that it doesn't damage the pump. So I made the pump housing an actual mechanical structure that can actually support more weight than the rest of the system itself. So the rest of the system, the containers, are the weak link. So if somebody should have enough common sense that if they stack enough weight on the container, it'll overcome the integrity of the containers.
Yeah.
But I didn't want our pump to be the weak link. I wanted the container to be the weak link because that's what people can see, and they won't hopefully overcome the integrity of the container. So anyway, that was my philosophy there, is to design the body of the pump so that its structural capacity is greater than the structural capacity of the container it's in. Anyway,
so do you think the cycle time is like 1 minute per part or 5 minutes per part? How long does it take to like inject the plastic and then let it cool and then
I would say the cycle time is probably in the 25-30 second range.
It's not much at all.
Yeah, it's not very much at all. But there's cycle times that are much, much shorter. I mean, if you're designing a non-structural part, you keep all of the plastic as thin as you can to do its job, and you know, to support the forces that it sees. And you can get those cycle times down to you know, 5 or 6 seconds.
Yeah, I haven't had a lot of experience. Well, I've had a lot of experience in manufacturing. I've probably seen a couple of hundred manufacturing plants, but I've not seen, it strikes me as that none of them were doing injection molding. Closest I came was a dairy, not a dairy, kind of a bottling plant called Stephen's Dairy in Wichita, Kansas. And they had just introduced a blow molding machine in like 1963 or so, maybe even less, maybe even 1960, that this blow molding machine was making these plastic milk jugs at about 1 every 10 seconds or so. It was really fascinating.
Yeah. So when you're working with thin plastic, you can get the cycle down. And they also, if you want to spin them, if you tell a manufacturer, my concern is to get the price of this part down as cheap as I can get it,
Mm-hmm.
and you have the money for the tooling for that, they're now 3D printing the mold bases, and they're 3D printing the cooling channels in so that they can get absolutely optimal cooling, and they can get that cycle time down. But you know, that's very expensive tooling, right?
Oh, yeah.
So there's ways. I mean, when we have the funds to invest in tooling, then we can get those cycle times down. And that's why I keep saying, you know, we'll eventually get to a pump that's costing us 25 cents.
Wow. Wow.
You know, we just have to get the funding to get the tooling that will get us there, because even our other pump that has the housing involved in it, I mean, we're talking about 5 to 10 cents worth of plastic. The amount of plastic is insignificant. It is all about the cycle time and how many parts are coming out of that tool with each cycle.
Yeah.
So when we get into the point that we're creating hundreds of thousands of systems that we're sending out to humanitarian aid, those will have a pump that's we'll have a mold that's producing 4 pumps at a time, and it'll be, you know, a 10 to 15 second cycle time. And, you know, so it'll be all in the cost of that mold, but it'll get the price of those pumps down to about a quarter. And of course we won't have to assemble those pumps. There'll be we'll still have to assemble the pumps, but it won't be as many components as this pump is.
So how did they ever create stuff like this before CAD, before SolidWorks?
They have long cycle times. We made parts that we didn't make parts that had these kind of nice organic shapes to them. We made parts that were square, rectangular, or round.
Mm-hmm.
Right? Remember, just think back to the 60s and the 70s. Every product that you had was pretty much rectangular, square, and if it didn't have those shapes, it was because it was a sheet metal product.
Mm-hmm.
But plastic products, I mean, think about all the VCRs and the TV cabinets and anything that was plastic back then, radios, right?
Yeah.
They were all square, rectangular. They were boxy, or they were round, because the amount of programming to make this shape back in the day, we would have figured out how to get rid of all these angles and everything.
So are all these molds steel or aluminum, or how do they machine and actually make the mold with the cavities to those specifications?
So they're steel, and this mold is pretty straightforward. There's some inserts that they will run on a lathe for doing all these like this mold here, that's what these are. These are mold inserts, and those will be made on a lathe because they can machine the a round cavity so much faster with a lathe
Yeah.
than they can with a mill. So they'll lathe these components, and there'll be some CNC machining on the inside, but a lot of that will be done with a lathe. And so that's how they speed up that process. But these will just be CNC cavities, and they just literally plug these parts that I've designed into their software.
Yeah.
And I designed these so that they're very easy to machine. And one of the reasons I went with a wall thickness, I can get the wall thickness of these parts down. However, it would cost substantially more to make the mold with a thin wall thickness.
Yeah.
So I opted for a higher priced part, longer cycle time, in order to get the cost of the mold down so that we could get a very affordable mold, because we can amortize the cost of the part into future sales much easier than we can afford the upfront cost of an expensive mold right now.
Awesome.
So anyway, we are getting our money's worth. That's a very sophisticated mold. I expected a much simpler mold for what they quoted. I expected this first mold to be a simpler mold, but these guys are an extremely sophisticated shop, and I suspect that they may have had a large order that changed manufacturers or something, and so they're looking to keep their shop busy. So I suspect that we got into this shop because of timing.
I got it.
Because this is way more than a $2,400 mold. This is this is a $5,000 to $8,000 mold right here.
Wow, that's awesome. Well, I hope you all enjoyed that as much as I enjoyed it, because it just is a testimony to Shane's genius and his experience at creating manufacturing, actually his genius in manufacturing the wizardry that his mind comes up with. So it's not just about being an inventive genius, it's about actually having the experience necessary to create these things in mass volume with reliable quality at a very fair price. I hope you enjoyed it as much as I did. Talk to you next week.